Warm welcome to everyone. I myself Alagu Sankereswari, Department of Civil Engineering from SKR Engineering College. Today I am going to discuss about the Mohr circle, that is a stress transformation. Before going into the topic, let's have a glimpse of some basic terms used for this construction of the Mohr circle. That is, I am using what is a stress transformation. Before that, what is meant by stress? There are many types of stresses, that is tensile stress, compressive stress or shear stress. It plays a major role in the civil engineering. The tensile stress is nothing but the load which is acting above from this one. This is a tensile stress, and compressive stress is nothing but the body which is subjected to the shear stress. Then next one is when I am giving the load externally, what happened to this material? This is a shear stress of the material. So these are the basic terms, that is tensile stress, compressive stress and the shear stresses. It should be incorporated in the civil engineering. Why means we need to design a structure, means it should be resisting the internal resistance of the material when it is applied load on the external of the material. So in order to restrain that material, we need to know the major principal stresses and what are all the normal stresses acting on that material. These are the two backbones of the civil engineering, that is the principal stresses and the principal normal stresses. So in order to know the major principal stresses and the minor principal stresses, we need to know the construction of the Mohr circle. Initially it was discovered by the German engineer, the Otto Mohr. That's why the name has came Mohr circle. So for why we need to go to the Mohr circle? So usually we will know the 5 W and H, that is where, when, why, what and how. This is some things, whatever the topic we are discussing, we need to know the basic concept of this. So where we are going to, why we are using this concept is, if you know any plane, if you want to design or any type of design we need to design, means we need to know where the normal stress is maximum or where the normal stress is minimum at any specified point, or each plane have the different normal stresses in different directions. So we need to locate where the normal stress will be maximum. That normal stress is called as a major principal plane, and the normal stress on the principal plane on which the maximum stress is acting is called as a major principal stress, and the minor principal plane is the which is having the lower, that is a minimum or lowermost normal stress, that is called as a minor principal plane, and the stresses acting on that minor principal plane is called as a minor principal stresses. So let us look at now the in depth of the stress transformation, that is a Mohr circle. Initially I have taken the plane stresses. In the plane stresses there we need to know the normal stresses and the shear stresses. The normal stress is nothing but the sigma x. That is sigma is nothing but the stress. This x indicates the plane. Initially we need to know is if xx is indicates is nothing but the subscript indicates x plane and x direction. So we need to know the stress tensor, that is sigma yy and sigma z, and then tau xy, tau xz, sigma, that is tau yx, tau yz, then tau zx, tau zy. This is called as a this is a stress tensor. What is the subscript indicates means the first one indicates the plane and the second one indicates the direction. This similarly it will be applied here. Now I have taken the two-dimensional transformation. So the Mohr circle is nothing but two-dimensional transformation of the stresses, that is expressed in a geometrical representation, and it is used to find out the most efficient manner. So sigma x is the stress, is the normal stress acting in the x direction, and sigma y is the normal stress acting in the y direction, and tau xy is the shear stresses. So already I explained what is the tensile stress and compressive stress and shear stress. So these are called as a stress tensor. This can be used by sigma I cube minus I1 sigma squared, then plus I1, that is I2 sigma, minus sigma is equal to 0. Sorry, I3 is equal to 0. This I1, I2 and I3 are the invariants used for constructing of the Mohr circle. Now, when I am rotating these plane stresses about an angle theta, it will move to the new axis. What is the nature of these forces I need to know? So, the transformation of the stresses from the xy coordinate to the x1, y1 coordinate is due to the rotation of this angle. So, x1, that is sigma x1 and sigma y1 are the now normal stresses acting in the x1 direction and y1 direction, and tau x1, y1 is the shear stresses. Now, the same thing if I am taking theta is equal to the principal plane, there is rotation of an angle, there is rotation of angle is nothing but unrotated element to the rotated element. If theta is equal to the theta p is nothing but the principal plane. When the theta is equal to theta p, then you can see it is equal to the sigma 1 and sigma 2, and you can notice that the tau xy is here is 0. Before that the tau xy is existing, after that the tau xy is not existing. Why is it means when it is converting means it is sigma 1 and sigma 2 is called as a major principal stress and minor principal stresses. there won't be a shear stresses. So where the shear stress is 0, that is called as a principal plane. The major principal plane and minor principal plane. Now let us look at the for an example. Now the sigma in before that we need to know the basic sign conventions used in these concepts. The basic sign convention is for normal stress, if it is like this, it is a positive. If it is a tensile one, if it is a compressive, it is a negative. Or for the shear stress sign convention is look at the topmost plane alone where it is acting. Look at the topmost plane, it is moving in the positive x direction. So the shear stress here will be the positive. Suppose if your direction is like this, means you have to look at the topmost plane. Here it is moving in the negative x direction. So the shear stress for the sign convention is negative. Now let us look at one example. The sigma that is the shear plane stress is indicated by sigma x and sigma y and tau xy. Here we can indicate sigma x is nothing but 200 megapascal and sigma y is 100 megapascal and the tau xy is 50 megapascal. Why? It's everything is positive as sigma x, it is moving in the positive x direction, and sigma y is moving in the positive y direction, and tau xy is moving in the topmost plane is moving in the positive x direction. So I have written positive in every manner. So to construct the Morse circle, we need to know the center, or we need to know the diameter of the circle. So for that we need to know tau, that is sigma average. Sigma average is nothing but sigma x plus sigma y divided by 2. So we know what is the sigma, we know the sigma y divided by 2 means we will be getting, that is 100 plus 200 divided by 2 will gives you the 150 megapascal. So this is how the center of the circle. So to construct the Morse circle, we need to know what is the horizontal axis. Whenever we need to draw a graph, we need to know what is the horizontal axis and what is the vertical axis. So horizontal axis is nothing but sigma and vertical axis is nothing but tau. It is a positive tau and it is a negative tau. Now what is the first one? Sigma x is a positive one. So sigma x I am locating. Then sigma y is the 100 megapascal. I am locating the sigma y. Now let me take, I have distinguished some planes, that is A1, B1, A2, B2. Why I have named this is to distinguish each planes I have distinguished. Now let me take A1 and B1. Now what is a A1? It's we need to write the coordinate of this axis. That is A1 is nothing but the plane is moving on. A1 coordinate, how we need to find it is sigma y is there and tau xy is there. So your coordinate will be sigma y comma tau xy. Since everything is in positive mode, we are having the positive. Then we take the B1. We are having the diagram is like this. So your coordinate will be sigma x. This is sigma x. This is tau xy. So it is in the topmost plane. You have to see it is moving in the negative red direction. So it will be minus tau xy. So these are the coordinate we are having. Now we have the sigma x and sigma y. Let me take A1 coordinate is sigma y comma tau xy. So sigma y, your positive tau xy will be here. Then B1 coordinate will be sigma x minus tau xy. So sigma x minus means it will be coming down. So it is tau xy. Now let me join, this is A1, this is B1 coordinate. So A1 coordinate is nothing but sigma y comma tau xy. B1 coordinate is nothing but sigma x minus tau xy. Now let me join this coordinate. Yes. Now this coordinate is nothing but we have already signed out the center of the circle, which is nothing but sigma average comma 0. The sigma average is nothing but sigma x plus sigma y divided by 2. So we have to locate the sigma average. It is nothing but sigma average. With this as a center and this as a radius, you have to construct the Morse circle. This is the Morse circle. So this is nothing but the tau max. We can, using this we need to find out the we have to theta. Here the theta is nothing but 90 degree. So the stress element, if it is theta is 90 degree, means when you are drawing in the Morse circle, it should be the twice of that angle. So here the theta is 90 degree means twice that of the angle is 180 degree. So when I have drawn this is in a straight line manner. So it is nothing but 2 theta p is, this is the positive direction. To find out the 2 theta p, I am having the formula, that is this is tau xy. This is tau xy. This is a sigma x minus sigma y. So nothing but 2 tan theta p is equal to, that is tan actually tan theta p, 2 tan theta p is equal to opposite by adjacent. So it's nothing but 2 tau xy divided by sigma x minus sigma y. So taking the tan inverse of this, 2 tan theta p is equal to tan inverse of 2 tau x by sigma y. So here it is 0 theta. So our tan inverse of 0 will be the 90 degree. It is nothing but theta p is equal to 45 degree. So like this we can find out the, at each point we can find out the theta angle. Then now the radius of the circle we need to know. For example, if we need to find out the radius of this circle, we need to find out by root of sigma x minus sigma y divided by 2 the whole square plus tau xy the whole square. Using this we can construct the Morse circle in efficient manner so that we can find out where the maximum principal stress will occur and where the maximum normal stress will occur, and we can locate the easily and then analyze the design. Thank you.